SpaceX's Starship high bay is being ripped apart just like our hearts. A never-ending brigade of concrete is flowing into Pad B's flame trench. We are closer to discovering a significant plot twist in SpaceX's Starship development. A legendary space telescope is signing off. NASA's Cygnus craft damaged in a shipping container. New contracts galore for Rocket Lab. Gravitics is building a spacecraft carrier. ULA gets Vulcan certified for Space Force missions. My name is Slim Shady.
My name is Slim Shady.
Happy April Fool's Day, welcome to What About It, let's dive right in. I revisited Starbase last week, finally, and what I saw was nothing short of stunning again. This place continues to be a hive of activity, as has been the case for well over half a decade now. It's changed so much since my first visit in 2020. Inspirational is not a strong enough word for it. Lately, ship maneuvering and relocating have calmed down a bit, and we're mostly focused on two main happenings: the high bay deconstruction and the development of Pad B, Starbase's future. And there is a focus on the flame trench. Last week we mentioned that over 300 concrete trucks had joined to help bring the flame trench at Pad B closer to completion, but as most of us expected, this project will need way more than that. Recent aerial photos of the trench still show plenty of unfinished areas, and then there is the dilemma about laying the concrete. At this point in the video, search the Hoover Dam concrete problem, not something SpaceX wants. Considering the sheer size and scope of the trench, it can be roughly estimated that the initial pour of concrete may have been about a third of what is needed to finish the trench, including ramps and walls. That being said, it wouldn't be surprising if we saw another 600 to 700 trucks filling in concrete over the next weeks to finish the job. Yep, it can take around 1,000 concrete trucks to create this flame trench. SpaceX has also been more active in testing the Pad B chopsticks lately. In addition to raising them to the full height last week, they've also done opening and closing tests. We're getting there. In terms of Starship prototypes and the super heavy boosters, there is a massive test to look forward to. A booster is getting ready for its static fire test. While we've seen many of these super heavy static fires by now, this one may potentially be a big plot twist. We have a road closure announcement for non-flight testing for April 3rd from 7 AM to 7 PM Central Time, with a backup the next day on April 4th. This is very likely for a booster static fire, and as soon as SpaceX rolls that booster to the launch site, we'll finally know if SpaceX will attempt the first super heavy booster reuse or not. If they roll booster 16 to the pads, it's a new one. If it's booster 14, SpaceX is going for it. This would be an incredible feat, considering that super heavy boosters have just started to return to the launch site after a launch. Go SpaceX! What do you think? Now's your chance to place a bet: 14 or 16? I'm rooting for 14. Shout out to Jordan Guidry, our photographer. I just went to Starbase with Jonathan from our team to meet Jordan for the first time. Thank you, Jordan, you are a fantastic guy. Elon Musk hinted last week that SpaceX is pressing on towards Block 3 of Starship, after two consecutive earlier than anticipated destructions of ships 33 and 34. But what about the super heavy booster? Are we closer to a Block 2 variant of it? A sighting at the build site might offer some answers. RGV aerial photography snagged this interesting shot at what appears to be a new generation of booster test platforms at the build site. These will be necessary because we'll see a shift from 33 to 35 Raptor engines, and maybe the long-awaited Raptor 3 engines too. When will we see the first Block 2 booster prototypes rolling around the build site? The movements and locations of this test stand might offer future clues to those questions. Ship Block 3 and Booster Block 2 will be major milestones for SpaceX. I can't wait to watch those launches with you. Good times! If you like our reporting, you can help us out in covering even more. Help improve the channel and double check that you've hit the like and the subscribe button to stay up to date with our updates. It's free and it helps us bring you even better content. Thank you. On March 27th, the European Space Agency powered down its Gaia spacecraft, marking the end of a groundbreaking mission that spanned over a decade. The control team at ESA's European Space Operations Center in Darmstadt, Germany, carefully switched off Gaia's subsystems and sent the spacecraft into a retirement orbit around the Sun, ensuring it won't interfere with other missions. I'm not crying, you're crying. The craft launched on December 19, 2013 from Kourou, French Guiana, aboard a Soyuz rocket and has been a cornerstone of modern astronomy, mapping nearly 2 billion stars with unprecedented precision. 2 billion? That is a lot. Formerly positioned at the Sun-Earth Lagrange point L2, about 1.5 million kilometers from Earth, Gaia created the largest and most detailed 3D map of the Milky Way. It's revealed its structure, evolution, and even evidence of past galactic mergers. That's more than a fender bender. The mission also discovered new star clusters, contributed to finding exoplanets and black holes, mapped millions of quasars and galaxies, and tracked hundreds of thousands of asteroids and comets. Gaia's science observations officially ended on January 15, 2025, when its cold gas propellant used to maintain its precise spinning motion ran low after 11 years of operation. Following this, the spacecraft underwent several weeks of technical tests to refine future space astrometry missions, including adjusting its solar angle to study its brightness. This briefly made it visible to ground-based telescopes at a peak magnitude of 14. Not bright enough to see with the naked eye, but easy for a good telescope. On March 27th, the final commands were sent to shut down Gaia's communication systems and central computer. This ensured it remained silent in its new orbit. In tribute, the names of around 1,500 team members were written into Gaia's onboard memory, along with personal farewell messages as a lasting memento of the mission's human legacy. Its impact is far from over. 2 major data releases, one in 2026 and the final one by 2030, are planned, which will continue to fuel astronomical research for decades. Despite its success, Gaia faced challenges, including a micrometeoroid strike and a solar storm in 2024 that disrupted its sensors, though the team managed to restore its operations. Thank you, Gaia team. The spacecraft's retirement orbit was carefully chosen to avoid drifting back to L2, a scientifically valuable point also used by other missions like Euclid and the James Webb Space Telescope. Gaia's unparalleled map of the Milky Way has redefined our understanding of the galaxy, offering a legacy that will shape astronomy for generations. As space becomes more crowded, the challenge of sustaining long-term missions while avoiding interference with others will only grow, making Gaia's careful decommissioning a model for the future. Last week, NASA announced a significant setback for its International Space Station resupply plans, pulling the Northrop Grumman Cygnus spacecraft from its scheduled June mission after it was damaged during transit to the launch site in Florida. The transit gremlins strike again. The Cygnus, designated for the NG-22 mission, was being transported in a shipping container that sustained damage in what Northrop Grumman called a commercial shipping accident 3 weeks prior. After a detailed inspection, NASA confirmed the spacecraft's pressurized cargo module was also damaged, making it unfit to fly in the near term. This marks a blow to NASA's commercial resupply services program, as Cygnus is one of only 2 Western spacecraft currently capable of delivering food, water, experiments, and supplies to the ISS alongside SpaceX's Dragon. The next Cygnus mission, NG-23, won't launch until at least this fall, leaving a gap in the ISS supply chain. To compensate, NASA is adjusting the manifest for SpaceX's upcoming Cargo Dragon mission SPX-32, set for late April, to include extra food and consumables originally slated for Cygnus. Meanwhile, other resupply options like Sierra Nevada's Dream Chaser and Japan's HTV-X are still months away, with launches projected for late summer and fall respectively. This incident highlights NASA's growing reliance on SpaceX, which now operates every non-Russian vehicle flying to the ISS, including Crew Dragon for human flights and Cargo Dragon for cargo. Northrop Grumman, which has been using SpaceX's Falcon 9 to launch Cygnus since retiring its Antares 230 Plus rocket, is working with Firefly Aerospace to develop a new Antares 330 rocket, but it won't be ready until at least late 2025. Do you know what form of transportation is still reliable? Helicopters. Check out redlineheli.com/Felix for a once-in-a-lifetime experience and $25 off flying in a helicopter above Starbase. The Redline helicopter team is waiting for you. They'll show you the same views our photographers get on their Starbase flights. Give it a try. On March 26th, the US Space Force certified United Launch Alliance's Vulcan Centaur rocket for national security missions, marking a pivotal moment for the company after a thorough evaluation process. The Space Force's Space Systems Command reviewed 2 test flights in January and October 2024, accepting the rocket despite a booster nozzle failure in the second launch, which was traced to a manufacturing defect in a Northrop Grumman solid rocket booster, but mitigated by the rocket's Blue Origin BE-4 engines. Good job, Blue Origin! Vulcan now joins SpaceX as the only other provider for the National Security Space Launch Program. Its first missions, USSF-106 and USSF-87, are scheduled for this summer from Cape Canaveral Space Force Station to deliver sensitive payloads to high-precision orbits. Designed to replace ULA's aging Atlas V and Delta IV rockets, Vulcan features a high-energy Centaur V upper stage. This enables it to tackle complex orbital insertions critical for countering space threats from other nations that may be testing anti-satellite technology. ULA plans 12 launches in 2025, including Amazon's Project Kuiper satellites in April. It's about time. By year-end, the goal is 2 launches per month, though managing a backlog of 70 missions could stretch their resources. Vulcan's certification gives the Space Force a second trusted rocket for national security launches. Let's hope things go smoothly. And you can become certified too, as a bona fide member of the Y community. If you appreciate the content, become a channel member or a patron for extra content. Secure your access to up to 7 picture galleries per week, satellites, aerial and ground photos, and 3D animations. Chat with us and gain more insights on the topics you love. Thank you so much for your support. Gravitics, a rising star in space infrastructure out of Marysville, Washington, recently landed a big and important contract with the US Space Force. The company announced they've secured a strategic funding increase known as StratFi, worth up to $60 million through SpaceWorks, the Space Force's innovation arm. This funding will fuel the development and flight of their revolutionary orbital carrier, a spacecraft designed to act like a launch pad in space, pre-positioning satellites for rapid deployment. That is so sci-fi. The orbital carrier bypasses traditional launch constraints, allowing operators to deploy satellites into any orbit on demand. This capability could transform how we respond to threats in space. It's a cylindrical module packed with maneuverable space vehicles and is built to house satellites with folded solar panels that are ready to spring into action when needed. Gravitics Carrier aims to give the Space Force a faster way to deploy assets, potentially as early as 2026, though no firm timeline has been set. Beyond military use, the technology builds on Gravitics' work in commercial space, including a $125 million contract with Axiom Space in 2024 to develop a pressurized module for their space station. The StratFi funding, a mix of up to $30 million from defense agencies and matching private funds, marks a big step for Gravitics, a company already adapting its commercial space station tech for both military and civilian applications. This contract is part of a broader $440 million SpaceWorks initiative, with 8 companies, including Gravitics, selected to advance space innovations. While the specifics of the carrier's capabilities remain under wraps due to the project's sensitive nature, the potential is clear: a new era of rapid response space operations. Gravitics is reimagining space deployment with a carrier that could outpace traditional launches, giving the United States a strategic edge in an increasingly contested orbital landscape. Intuitive Machines just dropped a major announcement. No, the lander hasn't risen from the dead. But after 2 tough lunar landings, the company is diversifying its ambitions beyond just touching down on the moon. CEO Steve Altemus laid out a bold new vision, emphasizing lunar data services as the next big frontier. Their most recent mission, the Athena lander, hit a snag on March 6th when it tipped over into a lunar crater during landing, severely limiting its solar panel's ability to generate power. No power, no mission. This marked Intuitive Machines' second consecutive landing mishap following their IM-1 mission in February 2024, during which the Nova Sea lander also tipped over after a leg broke during descent. Man. These setbacks have highlighted just how tricky lunar landings can be, even for a company working under NASA's Commercial Lunar Payload Services program known as CLPS. Now, Intuitive Machines is looking to the stars with a plan to build a network of 5 data relay satellites in lunar orbit, creating a lunar communications backbone for future missions. The first satellite is slated to launch in 2026 alongside the IM-3 mission, with the remaining 4 following in 2027 and 28. This network aims to provide reliable data transmissions for lunar operations, a critical need as NASA and private companies ramp up their presence on the moon. The company is also working on a lunar rover to support NASA's Artemis missions, which aim to return humans to the moon, and a larger lander, Nova-D, capable of carrying bigger payloads to the lunar surface. So landings aren't off the table for Intuitive Machines. CEO Steve Altemus is set to take the stage today at a House Science Committee hearing to discuss the future of NASA's CLIPS program, which has been a cornerstone of Intuitive Machines' work. Altemus is expected to advocate for an extended CLIPS 2.0, pushing for larger landers, more commercial services, and a broader role for private companies in lunar exploration. It's a critical moment for the company, especially since CLIPS has had mixed results. While Intuitive Machines has struggled with landings, competitor Firefly Aerospace achieved a full successful lunar landing. Another CLIPS partner, Astrobotics, experienced its own failure in January 2024 when its Peregrine lander suffered a fuel leak and failed to reach the moon. Here's to wishing Intuitive Machines the best of luck going forward with its endeavor. Keep pushing. China's space agency has announced launch dates for 2 of its most ambitious planetary missions. The Tianwen-3 Mars Sample Return mission will launch in November 2028, aiming to scoop up Martian soil and rocks with a robotic arm and drill and return them to Earth by 2031. That's fast. Tianwen-3 will rely on 2 Long March 5 rockets to deploy a lander, rover, and return vehicle to Mars, searching for evidence of past life in the planet's soil. This could outpace NASA after the US agency's Mars Sample Return program ballooned to $11 billion and got pushed back to 2040. Will I even be around by then? Rocket Lab has proposed a Mars Sample Return mission to fix this problem. We talked about that on episode 450, watch it to learn more. Just a month later, in December 2028, China will send a spacecraft to the Jupiter system. Man. It will arrive in 2035 to study the gas giant, orbit its moon Callisto, and survey other icy moons like Europa for signs of habitability, with a bonus Uranus flyby planned for 2042 on the return trip. The Jupiter mission will tackle the harsh radiation environment around the gas giant to explore its moon's potential to harbor life. China also confirmed its Tianwen-2 mission is on track for May 2025, targeting the near-Earth asteroid Kamo-Oalewa for sample collection before heading to study a comet. As a fun fact, Kamo-Oalewa means oscillating celestial fragment in Hawaiian. What makes this stand out? China's packed schedule could see it beat NASA to the Mars Sample Return, a historic milestone. Still, its insular approach might limit the global impact of its findings, especially when space discoveries thrive on shared knowledge. So please, China, share. In other Rocket Lab news, their HASTE program is accelerating the pace of hypersonic testing, pushing speeds beyond Mach 5 with a focus on affordability and launch frequency. Built as a rapid response solution, HASTE is designed to solve one of the US defense sector's long-standing problems. Hypersonic testing is too rare, too expensive, and too limited in scope. Several years ago, the Secretary of Defense directly addressed this challenge. Hypersonic vehicles, which travel at more than 5 times the speed of sound, require entirely new testing approaches. Traditional systems, like large solid-fueled rockets, often cost hundreds of millions of dollars and provide only seconds of usable test time. Smaller sounding rockets are cheaper, but rarely generate enough data for meaningful results. The HASTE system is built on Rocket Lab's proven Electron launch architecture. It uses the same first and second stages found in orbital missions, but it swaps the kick stage with a custom configuration designed for hypersonic re-entry profiles. With liquid fuel propulsion, HASTE allows for adjustable thrust, variable flight paths, and more controlled data collection. The result is a reusable testing platform that can support boost glide profiles, parabolic re-entries, or direct injections, all on a more frequent schedule. To date, HASTE has completed 3 successful launches, with more missions planned throughout the year. The Missile Defense Agency, the MACH-TB program, and other defense contractors are already using it. Each mission targets different objectives and trajectories. Unlike older platforms, HASTE can fly often, iterate quickly, and adapt to specific payload requirements. This approach could be a game changer for the development of next-generation defense systems, including high-speed interceptors, maneuverable re-entry vehicles, and advanced thermal shielding. Rocket Lab's goal is to provide a flexible and consistent testing environment that can keep up with the pace of modern development rather than slowing it down. It shows space access isn't just for satellites or research anymore. It's key to national security testing, and Rocket Lab is deeply involved in the path forward. That's it for today. Remember to smash that like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. A new Raptor design and our brand new Starship Block 2 design are both up. Link is in the description and in the card you should see now. Also, check out our print store at shop.whataboutit.space to buy a picture for your favorite wall. A significant amount of every purchase goes directly to Jordan, our photographer. And if you want to learn more about why the Starship doesn't have any legs, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode. Major milestones for SpaceX. Several weeks of technical tests. What? Ooh. Ah. Good times.